In my recent Ortega method tutorial, I briefly explained cube notation. Then, I realized two things. First, I didn't want to explain cube notation in every beginner or maybe even advanced video. And second, I think the explanation in the Ortega method tutorial is too oversimplified and that it might raise some questions. So now that I realized how fun it was to make tutorials, I'm going to make an entire video tutorial about cube notation. So this video tutorial for cube notation will cover basic cube notation and also some more advanced cube notation. And actually the cube notation for this is specifically only for 2x2 and 3x3 and will not cover the big cube notation because, well, it's essentially the same, although there are more stuff for the inner layers, but for now we'll only be focusing on 2x2 and 3x3 cube notation. So with that, let us begin. To put it simply, cube notation uses a string of letters to represent a set of moves on the Rubik's Cube. How, you may ask? Well, let me show you an example first. So for this example, I will use this 14 move algorithm I'm about to show on screen. So without cube notation, how I would describe that 14 move algorithm would be like this. Now I'm sorry if I broke your brains by showing that entire thing, but if we did use cube notation, all of that information can be compact into a small string of letters. Now that was only an example of why cube notation is really useful, but now let me show you how cube notation actually works. For each side of the cube, and I mean side, not color. So for each side of the cube, there is a letter that corresponds to that side. So the right side corresponds to the letter R. The left side corresponds to the letter L. The top side corresponds to the letter U for up. The bottom corresponds to the letter D for down. The front side corresponds with the letter F. And the back side corresponds with the letter B. Now, why I said side, not color, is because when you rotate the cube like this is now the right side. So earlier when I was facing green, red was the right side. But when I rotated it to red, red is now the front side and blue's the right side. So this changes basically on how you're looking at the cube, not by color. There's no specific color per side. So if I'm facing white now, then my right is red, my top is blue, my bottom is green, etc, etc, etc. Now let's get to actually moving the sides. So yeah, each side has a corresponding letter to it, but then when you move it, how much should you turn? You could turn it this much, you could turn it like this much. How much? Well, typically when you see a letter, then it just tells you to turn it 90 degrees. So when I see R, so R for the right side, it tells you to turn the right side 90 degrees. So if I see L, then it tells you to turn the left side 90 degrees. And if I see U, then it turn the top side 90 degrees. Same thing for the bottom, same thing for the back, same thing for the front. But then there are two ways you could turn 90 degrees. You could turn it clockwise or you could turn it counterclockwise. Now this is where the apostrophe comes in. Now the apostrophe or prime will tell you if you should turn a certain side clockwise or counterclockwise. So how to tell this is, first, if the letter is by itself, so for example R, then it just means to turn that side clockwise. So clockwise there, like this, so clockwise. And then if it's L, then clockwise on the left, so 90 degrees clockwise would look like that. Clockwise, remember, so that's not clockwise, that is counterclockwise. And then for U, turn the top side clockwise 90 degrees, so boom, clockwise. And then for D, clockwise also, that's clockwise. And then for F, front clockwise 90 degrees, and then the back front clockwise 90 degrees. So now if there's an apostrophe connected to the letter, that means to turn that side counterclockwise. So the apostrophe is actually read as prime, so R apostrophe, it's not read as R apostrophe, that's weird, it's read as R prime. So if I see R prime, then it means to turn that side 90 degrees counterclockwise. So there's counterclockwise. This one, that's counterclockwise for L. And this is counterclockwise for F. This is counterclockwise for B. This is counterclockwise for U. And this is counterclockwise for D. So quick recap of everything I said. There is a letter corresponding to each side, and you turn that side 90 degrees, and if there is no apostrophe on the letter, then that means you turn it clockwise, and then if there is an apostrophe or prime, then that means you turn it counterclockwise. Now let's apply that newfound knowledge to reading algorithms. So let's use this short 4-move algorithm as an example. R, U, R prime, U prime. You'll see this algorithm a lot in the 3x3 beginner method. Now, if we're going to read this, the first move is R. So it's R, so the right side, and there is no apostrophe, so then we just turn clockwise, so R, clockwise like that. And then the next move is U, and again there is no apostrophe, so that means we turn the top face or the upper face clockwise, so U. And then now it is R prime, there's an apostrophe, that means we have to turn that side counterclockwise, so R prime, there you go. And then it's U prime, which means we have to turn the upper face, the top face, counterclockwise, so U prime. So that one quicker, which is R, U, R prime, U prime. Now you may ask, what if we have to do a 180-degree turn like this? Do we just write RR? Well, no. We write 180-degree turns as the side and then 2. So if we want to turn the right side 180 degrees, we write R2. And then for the left side, it's L2. The top side, it's U2. Same for D2. Same for F2. And same for B2. Now, there is no R2 prime, as any way you do it, it's gonna be the same. So, yeah, that's it. Now, let's do a quick challenge. Here is a 4-move algorithm, but it's not written in cube notation. I want you to try writing this in cube notation. Pause the video and try it out before I show the answer. Done? Here's the answer. So, the first move says to turn the left side 90 degrees clockwise. So, the left side 90 degrees clockwise. So, since it's clockwise and it's the left side, then it's just L. Next, it says turn the front side 90 degrees counterclockwise. So, since it's counterclockwise now, you have to put an apostrophe after the F. So, since it's the front side, it's F, and then since it's counterclockwise, you add the apostrophe or prime. And then after that, it says turn the left side 90 degrees counterclockwise. So now it's the left side, but it's counterclockwise, so you have to write it as L prime. And then lastly, it says turn the front side 90 degrees clockwise. So you write F since F is for the front side, and then there's no apostrophe since it's clockwise. So it's L, F prime, L prime, F. So let's just do that few moves in a cube. Now, fun fact, that is called the sledgehammer. If you were able to do that, good job, you learned cube notation. If not, that's fine. Just rewatch this part of the video until you can finally understand. Now, people learning the 3x3 beginner method, or learning the beginner method for 2x2, or just anything in 2x2 in general, may leave the video here. But if you're about to go a little more advanced, maybe about to learn beginner CFOP, then this next part is for you. On basic cube notation, you basically learn all of the outer layer cube notation. So you learn R, L, F, U, D, and B. But there's also cube notation for the inner layers of the cube. So for this layer, and this layer. Now, the layers for those now is for this middle layer that you could do here vertically. This is M. For this one, it's E, you know, because it's like the equator, so it's equatorial or something like that. And then this one, this like sideways one, it's called S for slice. And mostly anyway, you're gonna be using M. You're not going to use E and S much, so this part is mostly just so you could learn M. Now, how do you determine which way is clockwise and counterclockwise? Since anyway I look at this is clockwise, but here this is counterclockwise. So which way do I look at it? So we have just connected the inner layers to other outer layer clockwise counterclockwise relationship. So I'll just tell you so that you can understand. So the M layer, this M middle, follows L. The E layer follows D, and the S layer follows F. So basically what that means is that whatever is clockwise and counterclockwise for L is clockwise and counterclockwise for M, which means this is M prime. M is this because this is L. So same thing for this. So since this is D, so this is E, and this is D prime, so this is E prime. And this one, since this follows F, since this is F, then this is S, and this is S prime because that is what's counterclockwise for F. Oh, also double inner layer moves also exist. So M2, E2, and S2. Now, just a few example of algorithms which use inner layers are the H perm. So this is the H perm. And the Z perm. Got all of that? Nice. But that's not the end for advanced cube notation. There is also a way to represent wide moves. So basically you're turning two layers, the outer and inner layer. So like this. So it's like you're turning an outer layer and an inner layer at the same time. That's already self-explanatory for double layer. So how we rate this is, it's basically the same thing for outer layer turns, but it's a small letter, and it also follows the same clockwise counterclockwise rule. So this is R, this is R prime, or small letters are either read as small r and small r prime, or wide R and wide R prime, whichever people use, but just know that they read it that way. So this is L prime wide, this is L wide, this is U wide, this is U wide prime, and so on and so forth. And that's double layer turns. It's pretty simple. Maybe some algorithms with double layer turns are mostly just OLLs, but they're in full OLL, so you might not know them yet, but I'll just show you this for an example. Now there's one more thing in advanced cube notation, and that is notation for cube rotation. So when you're going to rotate the cube like this, or if you're going to rotate the cube like this for an algorithm, or if you're just going to rotate this, then there is also notation for that. Now it'll be a little weird to explain, so buckle up. Now the letters used for cube rotations are X, Y, and Z. Now X are rotations like this, Y are rotations like this, and Z are rotations like this. I'm not sure if that's confusing or not, but here's a way to perceive this. So start with X rotations. Now, to imagine X rotations, try doing an arm move with only one hand. So, I don't mean you're doing literally one-handed. I'm not talking about doing arm moves one-handed. I mean an R wrist turn one-handed. So this. So basically, X rotations, clockwise and counterclockwise thing. It's prime and not prime thing. Follows R. So if I wanted to do X, this is X. And if I wanted to do X prime, this is X prime, because it again follows R. So it uses the same concept for Y and Z. You use a wrist turn, not a literal one-handed turn, because you could literally do that. I mean a one-handed wrist turn. So if it's now you're going to do it's actually just way easier on the left hand. So if I wanted to do a Y, now I hold it on U, and then I turn the U layer, but with only one hand like this. So this is, so if a U, a regular U would look like this. So a Y, which follows U, which was like this. And then Y prime would look like this. Same concept for Z rotation. So since this is F and this is F prime, so I'm gonna do a front wrist turn. So a Z rotation, so a Z would be like this, and the Z prime would be like this. Now maybe some examples of algorithms with rotations in them. They're mostly full PLL algorithms, but I'll just show them anyway. For X rotations, there's the E perm, which uses an X prime rotation at the beginning, and then you execute the algorithm. Now, an example of an algorithm with a Y rotation is the V perm, which is a pretty infamous algorithm just because of that rotation. So I'll show you that. That was so bad. If you made it through all of that, congratulations, that is it. The only things you need to learn now in regards of cube notation is for big cubes, because, well, mostly it is the same thing. So that's an R, this is an L, this is an F, yada yada yada. But there is specific notation for wide moves like these, inner slice moves like these, especially when you're learning the 4x4 parity algorithm. And there's also just very specific, like, there's just some stuff for, you know, these other big cubes. So 5x5 has its stuff, 6x6, well, basically these are just big cube specific stuff. So like, there's a way to know the difference between a turn that's this and a turn that's this, and even a turn that's this, but I will not be covering that in this video. So that's it. Thanks for watching. If you enjoyed that video and want to see more, consider liking and subscribing. And with that, I will see you in the next video. Bye.